Okay, in this lecture, we're going to be looking at determining the number of possible outcomes, and this is a really important concept. We're going to be doing this by using the multiplication formula, permutation, and combination formula. The reason why this is so important is we're looking at something that can occur, and we're going to say how many different ways can this occur? How many different possible outcomes can we have? And so we look at, like, for instance, let's see here. I've got one of those giant dice. We've got a giant die right here, and I'm looking at this die, and I say, okay, if I roll this one time, how many different possible outcomes can I have? So I roll it one time, and there are a total of 6 possible outcomes if I roll it one time. However, hold on. If I have two dice, how many possible outcomes are there? There are a total of 6 possible outcomes here, 6 possible outcomes here. How many possible outcomes are there? Well, that's a really good question, and so that's something that we're going to find out, because if we know how many possible outcomes there are, then we are going to be able to say, the probability of this very specific outcome, this is the probability of this very specific outcome. And so that's the benefit of knowing how many possible outcomes there are. Also, the probability of a set of possible outcomes. So in other words, if you have a certain number of outcomes in that set, divided by the total number of possible outcomes, assuming that all outcomes are equally likely. Like, for instance, what is the probability of this one landing between 1 and 3 multiplied by and what is, as well as the probability of this one landing between 1 and 3. So that's a set. So you'd be like, okay, 1, 2, and 3, so that's 3, and so you've got sets, and so it'd be 3 out of 6 and 3 out of 6. So what's the probability of both of these landing in 1 out of 3? And so later we're going to be using, those are all assuming that all outcomes are equally likely. A little bit later in the unit, we're going to be looking at how to use these formulas when all possible outcomes are not equally likely. So I was getting into the multiplication formula with the dice just a minute ago. So this multiplication formula. Multiplication formulas are when you have a certain number of ways to do one thing and a certain number of ways to do another thing. Then there are m times n ways of doing both things. In other words, you multiply the number of ways that you can do the first thing by the number of ways you can do the second thing. You multiply those together to find the probability, or sorry, the number of ways that you can do both of those things, simultaneously, if you will. And so, like, for instance, with these dice, there are 6 possible outcomes here. There are 6 possible outcomes here. So what is the number of possible outcomes when I roll both of these together, assuming that these are 2 totally separate dice, and that we say the yellow dice rolled A and the red die rolled A. So there would be 6 and 6. You multiply the 2 of these together, there's a total of 36 possible outcomes that you can have between both of these dice, assuming that you look at both of these completely separately. Okay? In this particular situation, you have an automobile dealer who wants to advertise that for $22,999, a 2-door or a 4-door model with your choice of gray, blue, green, or orange, you can get a car. And so he wants to know how many different vehicles the dealer is offering for an advertisement. He was like, hey, I'm offering this many different types of vehicles. And so he looks at it and he says, okay, I've got a 4-door model, I've got a 2-door model, so there's 2 different types of doors. And then I offer 4 different colors. And so if I take 2, multiply it by 4, then I have the ability to say, I have a total of 8 different colors, 8 different models that I am offering. 8 different models that I'm offering. Okay, so there's 8 different models that they're offering. But what if he wanted to add one more element? Okay, like for instance, I have 6 possible outcomes here. Then I have 6 possible outcomes with the yellow die. And then what if I add a third die? So I've got now 3 different die that I can choose from. Well, all that I've got to do is just multiply it again by 6. So 6 times 6 is 36, times 6 is 216. So now there are a total of 216 possible outcomes because I added 1 more die. In the same way, if for instance this dealer looks at this and says, okay, we've got 4 different colors, 2 different types of doors, and 2 different trim packages for these cars, well, he's going to multiply it again by 2, so now instead of offering 8 different cars, he's offering 16 different cars. And so the multiplication formula, you just have to multiply it again by another option that's available. Okay. The permutation formula. In this particular situation, order matters. Okay. You have basically any arrangement of a certain number of objects or a certain set of objects is selected from a single group of n possible objects. So you have, for instance, a whole bunch of, let's see here, I've got a whole bunch of pens. I like pens. And all of these pens are different colors. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 different pens here. 16 different pens. And the permutation formula says, how many possible outcomes are there if I select a certain number of pens from this fistful of pens? But more specifically than that, I care about the very first one that you select, the second one, so say for instance I'm selecting 3, the second one, and the third one. I care because the first one is going to Johnny, the second one is going to Jill, and the third one is going to Jack. And it's really important that we know who's getting what color, so order matters. Order matters because it matters who gets what pen. So I'm selecting 3 pens and order matters. This would be a permutation formula. Okay, so for this particular situation, you would have n, which is the total number of objects that you can choose from. And then r is the total number of objects that's selected. So we have 13 pens that you can choose from, and then you have a total of 3 pens that I choose at a given time. So what this would be is 13 factorial over 13 minus 3 factorial. So it would be 13 factorial over 3 factorial. Okay, so I just paused that for a second and I wrote that out in case you're not super familiar with factorials. A factorial, you've got 13, so when I say 13 factorial, I say 13, 12, 11, 13 times 12 times 11 times 10, or times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all the way down, right? And then 10 factorial, which is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So the really cool thing about this is it's really not that bad. And the reason why is because the 10, all this right here, the 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, that all gets canceled out by what's underneath it. Okay, so home, let's see here. We're going to strike that out, and we're going to strike this out. And that means that we've only got 13 times 12 times 11. So let's work that out. Okay, so what's 13 times 12 times 11? So how many total possible outcomes of pens are there for Johnny, Jill, and Jack? There are a total of 1,716 possible different combinations that I can choose from, or possible permutations that I can choose from for Johnny, Jill, and Jack. And so it's really not all that bad once you learn, okay, just cancel it out. Another way that you can do this is do note on the bottom, you've got 10 factorial. So when you start listing them out, just go 13 times 12 times 11 times 10 factorial, and you can just cancel out the 10 factorial with the 10 factorial, which gives you 13 times 12 times 11, and then which equals, let's see here, what is it that we had? the 1716. Okay, 1716. And that's when you have 13 pens, but only 3 get chosen at a time. Okay, in this particular situation, we have the football team who's deciding on a new helmet. They have 4 colors. There's 4 colors that they can choose from: black, gold, white, and green. And no color can be repeated. Once again, in this particular situation, no color could be repeated with those pens. Okay. What will be on the face masks, letters, or helmets. So there's only 3 different things that can be chosen at a time. So what we have now is we have, let's see here, I'm going to back this up. We have 4 factorial, which is the number of possible choices, and then we have divided by 4 minus 3 factorial. So what's 4 minus 3? That's going to be 1. Let's see here. So we've got equals 4 times 3 times 2 times 1 divided by 1. And what does that equal? Which I've got to get rid of this. Sorry. Control. So 4 times 3 times 2 times 1 divided by 1. So you really can't cancel anything out. I guess you can cancel out the 1s. So it's 4 times 3 times 2. And so let's get out our handy dandy nifty calculator again. So what's 4 times 3 times 2 is going to be 24. So this right here, there's a total of 24 possible outcomes. You're looking at it and you're thinking to yourself, are there really 24 different helmets that can be made just from those 4 colors? Yes, there are definitely 24 different helmets that can be made just from those 4 colors if you choose 3 colors at a time. And so this is what it would look like. If the helmet was gold, here's all the possible combinations of the face mask and letters. If the helmet was green, here's all these possible combinations. If the helmet's white, here's all these possible combinations. And if the helmet was black, here's all these possible combinations. And so we've got this right here. So 4 over 1 factorial, which is, like I said, 4 times 3 times 2 times 1. And there you go. So moving on, let's see here. So the combination formula. With the combination formula, order does not matter. Okay, order does not matter. This is once again another counting formula, and that's useful in determining the number of possible outcomes. And so right here, which we've got the combination formula, we've got the number of total number of objects that are possible to choose from, and then we've got the total number that are selected at a given point in time. And so we've got n factorial, or the number that are possible, divided by the number that are selected factorial, multiplied by n minus r factorial. Okay, for instance, the candy store uses teams of 3 employees to work each evening. There are 7 employees available to work. How many different teams can be scheduled? Okay, it doesn't matter who's scheduled, when they're scheduled. All that matters is that they are scheduled. Okay, they're all equal. There's just a total of 7 people, and 3 can be chosen at a time. And so we have 7 combination sub 7 combination sub 3, if you will, which equals here's the formula, which is going to be 7 factorial over 3 factorial multiplied by 7 minus 3 factorial, or if you work all this out, 7 factorial over 3 multiplied by 4. And so the way that I would do this is I would do, let's see here, Control C. I would do 7 times 6 times 5 times 4. And I'll space this out. And why did I stop at 4? That's a really good question. The reason why I stopped at 4 is because I'm going to just get rid of this, get rid of the 4 factorial. Let's see here. That work? It's not letting me do it because it's a formula. But you can get rid of the 4 factorial, and you can get rid of that 4 factorial, which when you do that, it ends up as just 7 times 6 times 5 over 3 factorial, or 3 times 2 times 1. So we've got 3 times 2 times 1, which is 6, equals... Sorry if this is annoying with working out everything out. I guess you can always fast forward, so I guess I don't feel too bad about this. So equals this over 6. And when you have this over 6, you can literally just cancel out this 6. You can cancel out that 6, which gives you 7 times 5. And 7 times 5 is 35, or 7 times 5, 35. And so just by canceling out, you can really make this a lot smaller than what it is. And so I'd suggest just keep canceling things out. So that's the combination formula. Once again, what we're talking about is determining the total number of possible outcomes. When we determine the total number of possible outcomes, we can determine the probability of one very specific outcome. So for instance, what is the probability that one very specific group is going to be chosen? And the probability of that one very specific group is going to be, the probability of that one very specific group is going to be 1 divided by the total number of possible outcomes. Okay? So, what's the probability of one very specific group occurring? 1 divided by the total number of possible outcomes. That one group divided by every group that's possible. Or coming right here, what's the probability that we are going to have this one very specific helmet? It's going to be 1 divided by the total number of possible outcomes, or 24. Or if I were to say, what's the probability of us having a green helmet? Then with every other possible outcome, we would look at this and we'd say, okay, there are 6 different combinations that are, or 6 different permutations that include a green helmet, so then it would be 6 divided by 24. So 6 divided by 24, because there's 6 possible outcomes where the helmet is green. And so that's how we use these principles of counting. We're able to say we have this many possible that are included as that are deemed as successes, divided by this many that are total possible. So that's the end of that lecture. Hopefully this was beneficial for you guys. Yeah.